Welcome to homework.
In this problem, we have an hydrogen atom that consists of a proton at the center and an electron going. Now we need to first find out the electric potential set up by the proton at the orbital radius of 52.9 picometers. So let's take an orbital radius of 52.9 picometers, and we need to find out the potential at this value. Now we know the potential is defined as V is equal to kq over r. So that becomes equal to k. The charge of a proton is E naught over the value of r which we have, and by numerical substitution this value comes out as 27.22 volts. Then we need to find potential energy of the potential energy U is defined as Q into V. The Q in this case is the electron, because field is produced by the proton and electron resides in that field. So the net energy, potential energy in this case will be negative E naught into this value, which is 27.22 volts. Finally, our value is negative 27.22 electron volts. See, find out the kinetic energy of the electron. We need to find the net kinetic energy of the electron in this case. So the kinetic energy is defined as half mv squared. So we need to solve for v first. So we'll make use of that. Since the electron goes in a circular orbit, there has to be a centripetal force. So centripetal force formula is mv squared over r, and there is only one force which is binding the proton and electron together, which is the Coulomb force, and that is given by k q square over r square once again. So that gives us the value of v as k. Q is actually E in this case, E square over mr. So, and thus the kinetic energy at r equal to a naught. So at r equal to a naught, the kinetic energy is k is equal to half mv square, which is equal to k e square over 2a naught, and that's equal to once again 13.6 EVs. Now this is a positive value. Remember, kinetic energy is always positive. We need to find how much energy is required to ionize the atom. Now for this we can find out what is the total energy of this hydrogen point. The potential energy is minus 27.2. The kinetic energy is 13.6 EVs. So we can say the potential energy overall is minus 27.22 EV. And if the kinetic energy is 13.6 EVs, we can find out what is the net energy of the system. The net energy of the system is K plus U, which is equal to negative of 13.6 electron volts. So we see that the electron is currently bound in this system in the hydrogen with an energy of 13.6. In order to free so that it has no kinetic energy, we need to provide plus 13.6 EVs of energy. So the energy that we need to provide is plus 13.6 in order to